Hello, my dear students. Today we are going to learn about measurement and effects of heat. Measurement and effects of heat. You have heard about heat. You also must have heard about temperature. So the thing is that heat and temperature is something different, even though they are similar, but they are different. I would like to tell you when you take a substance, it consists of atoms. All the substances are made up of atoms, irrespective of their state, whether they're solid, liquid, or gas. All these substances consist atoms. These atoms actually vibrate. When they do vibrate, they produce heat. So this heat, okay, it can be measured. Okay, and there's a temperature for the substance also. So you must have touched a hot object. Like for example, if you take a cup of coffee or a tea, you will hold the handle of that cup because you know it is hot. You take it as like this, take it, it is hot. You just take it in this way. And there's a hand, you take it, then you have your coffee. So you understand that it is hot. When you walk in sun, that time also the sunlight comes and touches you, that time it hits you, you feel much more hot. If you play and you run, that time also heat is generated from your body due to higher blood circulation. I'm telling you various aspects of heat. Then also understand when you burn a cracker, that time also heat and light is produced. So in the previous cases like sun, at that time sun has a lot of energy inside that. Last lecture we also discussed how the sun give energy since it's a stars. Okay. Last lecture we also discussed about that. So when the sun gives you that light, it also gives you the heat. When you switch on a bulb at your home, the electrical energy is converted into light and heat. So there is also heat out there. So there are different forms of energy. Okay, the heat is just a form of energy. Always remember that heat is a form of energy, and we can measure the heat with respect to temperature. We can measure the heat with respect to temperature. But heat is also related to energy. Like if you have learned that, if you have observed, if you have got smart watches nowadays, how many calories you have burned is what generally show when you run. Okay, when you run or when you jog, after your exercise, it will show you how many calories. What is the calories about? Calories about is just energy. What is energy? It's again heat. Understood? So so you must have a different with the already I've given you a lot of examples with respect to sun, bulb, burning a cracker. Okay, when you fire a cracker, chemical energy inside that is converted into heat energy. When you put on a bulb, the energy that's electrical energy is again converted into heat energy. In sun, as I already told you in the last lecture, there is a nuclear energy which gives you the heat energy. So this generally this is the way forward. So I would like to make you focus on to the main definition of heat with respect to your syllabus. Heat is total kinetic energy of atoms in a substance. Okay, it's measure of heat contained in that substance. Okay, substance is a measure of heat contained in that substance. Okay, so what is the measure of heat? It says that whenever an atom is provided with some energy, start to vibrate. This vibration causes a lot of heat energy. So this heat energy can be kinetic energy. This is kinetic energy. Heat is nothing but a form of kinetic energy, but total kinetic energy. Now, what is temperature? Temperature is actually temperature of substance is related to average kinetic energy of atoms. It's related to average kinetic energy of atoms. Okay, we don't measure. If you see a bulb, electric bulb, it's always on the top, like 60 watts or 100 watts. Watts are watts. What is the unit of energy? Watts. Understand? Now we cannot measure with these watts with respect to temperature. Now, when you go outside during summer, the room temperature or the normal temperature may be in, especially with respect to our country, 36 degrees Celsius. 36 degrees Celsius is nothing but temperature. It's just a minute. Temperature. So it is temperature. The 36 degrees Celsius is temperature. But heat is something related to energy. Understood. So already I've given a lot of examples with respect to these things. So you have to understand when you read the textbook, you just go to word, go to the sentence, a lot of examples and also illustrated over there. So heat can be measured with respect to calories and kilocalories of joules. And temperature is measured in mainly 3 units. Temperature is measured generally in 3 units: degrees Celsius, degree Fahrenheit, or Kelvin. Degree Celsius, degree Fahrenheit, or Kelvin. And so degree Celsius is used in a general way. Like in day-to-day life, we can use degree Celsius or Fahrenheit. Kelvin is generally used for scientific purpose only. When we do with respect to experiments and all, that time we measure the temperature with respect to Kelvin. There is also conversion for this. I'll just write down the conversion for it. This is the conversion of Fahrenheit to Celsius or Celsius to Fahrenheit. Now, if you want to convert any temperature into Kelvin, degree Celsius have to be added. 273 should be added. 270 should be added to make it into Kelvin. So if 0 degrees is there, it is 273. Therefore, it is 273 Kelvin. Understood all of you? This part? Just go through it. I'll wait for 1 minute. Okay, fine. Now let us compare this unit of temperature with respect to different aspects of water, like boiling point of water, or we can say that different room temperature. We can let us compare it. Okay, I'll make a column for it. Okay, understood. Generally, we are much more familiar with degrees Celsius. So boiling point of water is 100 degrees Celsius equilibrium. Okay, with respect to Kelvin, it will become 373. How it will become 373? It is nothing but 100 plus 273. We get this value. This is the value 100 plus 273. Because already in conversion I told you, if you want to convert degrees Celsius into Kelvin, that time you need to just add 273 into the Celsius. Now Fahrenheit, it is 212. So 100 degrees Celsius is same as 212 Fahrenheit. Fahrenheit is generally we measure when we have temperature like when we have fever and all. So have you seen one or three of fever, 1 or 3 temperature? It is not with respect to Celsius, it is with respect to Fahrenheit. All 3 or 104 degree is not with respect to Celsius, it's always with respect to Fahrenheit. Now, suppose we have a 23 degrees Celsius in room temperature, it will be almost 72 degree Fahrenheit, or it can be 296. This we can do the same way. 273 plus 72, you will get 273 plus 72, you will get 296. Clear? So in this way, we will be able to understand. So let us do one sum with respect to this. Let us do one sum with respect to this. Let us convert 68 degree Fahrenheit to degree Celsius and to Kelvin. So 68 degree Fahrenheit, we will convert it into degree Celsius and Kelvin. Let us do that. Everybody remember the conversion. If you have not, you can refer to test. I just directly write down how the conversion goes on like this. Normal formula I will write it on. It is for Fahrenheit at minus 32 upon 9 equal to C by 5. Now here we have got Fahrenheit. We will substitute the 68 over here. So it is 68 minus 32 upon 9 C by 5. Everybody got this? So C will be is equal to 5 into, it's already done, is equal to 36. 36 upon 9. 9 4 you will get 20 degrees Celsius. You will get 20 degrees Celsius. That is 68 Fahrenheit is 20 degrees Celsius. Now it is easy to convert degrees Celsius into Kelvin. How will you convert it? You will just add 273 into this degrees Celsius. That is Kelvin will be equal to 20 plus 273. That is nothing but 293 Kelvin. Understood? Go through the sum one more time. We just converting this 68 degree Fahrenheit into degree Celsius and degree Kelvin. Okay. I'll give you few seconds to copy it down. Just go through it. Okay, I hope you have done that part. Okay, so next let us learn about one instrument which generally measures the temperature. Everybody know that which is the instrument I am talking about. It is nothing but thermometer. Thermometer we have seen in the different kinds of thermometer already. So you have got some thermometers your teachers must have shown in your laboratory. Even you may have one digital thermometer at your home to check by your mother, like if something happened, like fever and all happens, you can keep it and you check your. As a digital thermometer, we call it. It's digital. Earlier, we used to have a thermometer which with mercury. Nowadays, very few thermometers which use mercury we use because mercury is not safe for use. Because if you break that mercury bulb, it is poisonous to health. So we generally use digital, or we can also use thermometer which has alcohol inside that. Okay, so generally we have got thermometers which have alcohol inside that. Okay, so that's all. We will going to we are going to explain the next part with respect to different type of heat and how heat and temperatures is related to each other in the next lecture. I hope that up till this you understood all of you. Thank you so much. We'll continue in the next lecture. Take care.